Alright guys, let's get back to some volumes of revolution. So now we're going to look at revolution around the y-axis. Extraordinary stuff. So I've got the graph here of y equals x cubed. And my question is, what's going to happen, or like what are we going to get if I take, for example, this region that I've highlighted between 2 and 4, and I rotate that around the y-axis. So I'm going to attempt to do, there we go, so it's going to be like a circle like that, and a circle like that, and then it's going to make a kind of a vase shape. So we're going to have this big kind of 3D frustum of a cone, kind of, apart from this is obviously not actually a straight side. So what would the volume of this object be? This is actually not difficult at all. We can just look at what we've done before and adapt it to work for this, because essentially what we had in the previous questions was this stuff. The volume when you rotate around the x-axis is the integral between b and a pi times integral between b and a y squared dx. And what essentially we've got here is the same thing, except for we're rotating it around the y-axis. So we can just kind of think like, well, essentially what we're doing is we're just swapping the axes we're working around. Like now, if we imagine this being the like height of the shape, this would be x, and then this is the y-axis that we're rotating around instead. Whereas before, we were looking at like the height of the shape being y and the x-axis being the one we were rotating around. So, I mean, it kind of seems a little bit obvious that we could just say, well, the volume is pi times the integral, but this time instead of being y squared dx, we're going to say it's x squared dy. And we're just going to, what the hell is that there? And we're just going to think to ourselves, well, we'll just think of this as being, instead of y equals f of x, which is what we've kind of got here, we're going to think, well, x equals f of y. Or this, I suppose we'd say g of y because I've just used f. But we're gonna think of it being x equals f of y. So x is a function of y instead. So if the line is y equals x cubed, then x is actually equal to the cube root of y. So for example, for this question, let's just do it. We're going to have the volume being pi for so between 2 and 4. So x would actually be y to the third. So y to the third squared dy. I'm doing that weird y again. So x equals y to the third, and then so x squared is y to the third squared. So we're going to just simplify this. So pi for 2 y to the 2 over 3 dy, and then when we integrate, so we're going to have pi, and then we'll do our integral here. So this would be 5 over 3, and then here this would be 3 over 5 between 4 and 2, like that. And then we just work it out. This seems like it's going to be kind of annoying to work out because it's not very nice numbers. I've just picked it at random. So we're going to have pi times by, oops. So pi multiplied by 3/5. So I suppose I can just take the 3/5 out like I did before, can't I? So let's just put 3/5 here. So 3/5 pi times by 4 to the 5 over 3 minus 2 to the 5 over 3. So that's what we're working out. There is probably a nice answer to this, but let's just get our calculator and work out what it is. So as you can see here, I put that in, it gives me 6.9. It is possible that we're not going to spend too much longer talking about this, but it is possible that you could have to write this in index form somehow. Like, I don't know, like for example here I'm thinking, well, 4 is actually 2 squared, so 4 to the 5 over 3 is actually 2 to the 10 over 3, and then we can maybe like start manipulating it. It seems pretty unlikely. To be honest with you, they'll probably give you something that'll give you an exact answer. But this is 6.90 times by 3 pi over 5. I can't be bothered to work all that stuff out. Anyway, this is going to lead us to doing exercise 5b. If you want to practice some questions like this, you really shouldn't find this too difficult if you've done 5a and found that alright. So you can pause here, do a bit of that if you want. I'm going to go straight on to looking at general shapes and stuff. So this is the classic bit of integration where you think, okay, well I want to find this area now, like instead of the whole area, because now I have to take away a shape or something like that. So like in a normal integral, if I just said find this region, you'd integrate between 1 and 3, and then you'd take away this triangle. So now what I'm saying is, if I rotate this region around the x-axis, what will I get? And I need to think, well, what kind of shape do I need to take away? And if you just do, just think about it, like what kind of shape would it be? It would be a cone. Okay, so you could pause here and have a go at this video, this question yourself if you want. This is an exam question. It's actually only part B. The overall total marks for this exam question was 10. This part was actually only worth 3 marks because in the previous part you'd worked out what R is. And this is actually from the old regular A-level maths, so might be worth less marks in further maths, let's be real. So anyway, have a go at the question. I'm going to go through it any second now. Right, let's do this. So what I'm going to do is I'm going to work out the whole region, and then I'm going to take away this 1 to 3 area, which is this bit here. So this will form a cone shape when I rotate it around the x-axis. And what we can think about is if it makes a cone, the radius of the cone is actually going to be the height of the graph here. The radius of the base, I should say, would be 2, and the height of the cone would also be 2. So this should hopefully be a pretty okay little bit of maths for us to do here. So let's just find the whole area first and then take away the cone afterwards. So the volume of the whole area is going to be pi integral between b a y squared dx, because we're going around the x-axis, not the y-axis. So pi integral between 3 and 1 of x plus 1 over x squared dx. And we're just going to figure this out. So we're going to have pi times, so 3, 1. So if we work out this, it's going to be x squared plus 2x plus 1 all over x squared. So this is actually really easy integral. Don't be a wally and try and do like something weird here, like partial fractions or something stupid like that, or whatever. Okay, we're just going to split all the terms. This is going to be x squared over x squared, which is 1, 2x over x squared, which is 2 over x, and then 1 over x squared. So when we simplify that, so we're further mathematicians, so I'm going to do this pretty quickly. So there we go. We should get this to figure out. And this, I'm just going to say do this in your calculator, because save a bit of time. Okay, I just realised I cut out the bit of the question that says this has to be an exact value, and it's pretty obvious that it has to be an exact value, because this is actually going to integrate to ln x. So don't do this in your calculator. It has to be an exact value. This is what you get in your calculator. It's probably not what we want. So let's just do it. I mean, you guys are probably way ahead of me already in this. So here we go. Pi. So, oops, I'm drawing the integral sign again for no reason. There we go. So, x plus 2 ln x minus x to the minus 1 between 3 and 1. Alrighty, and we'll put in the numbers. So, pi. So 3 plus 2 ln 3 minus third minus 1 plus 2 ln 1, which is 0, minus 1. So what do we get from this? So this is nothing. 2 ln 3 multiplied by pi. So 3 minus 1 plus 1. So that's actually, well, this is entirely 0, isn't it, obviously? So it's just going to be 3 minus third plus 2 ln 3. So 3 is 9 over 3. So this is going to be 8 over 3 plus 2 ln 3. Like that. So I mean, we can just say that's the answer for the entire revolution. Okay, so this is the whole area. So this is a whole volume, sorry, whole volume including cone. So now we just need to take away the cone. So the cone, so the red cone, let's do it in red. Oops, scrolled by accident. So cone is going to be pi times by, so we've got the formula here at the top, so third pi r squared h, so third times pi times r squared, which is 2 squared, times 2, so this is 8, so it's going to be 8 over 3 pi. Oh, well, would you look at that? That's quite nice, isn't it? Because if I do the volume of the whole thing, take away the volume of the cone, it just leaves me with 2 pi ln 3. So we can just say now from all of this stuff, so this and this together is going to give us the volume of R is 8 pi over 3 plus 2 pi ln 3 minus 8 pi over 3, which is just 2 pi ln 3. That's quite good, isn't it, the way they did that? Very nice. So, final question I'm going to look at is a bit of a modelling question. It's the only question like this I could really find where it's inverted commas, modelling, real life maths, all that good stuff. So, this is from the 2017 specification specimen papers for AS Further Maths. So, there's a cross-sectional diagram of a bird bath, which is circular, so you can see it kind of makes a kind of part of a sphere sort of shape there, which is made of concrete. So this is entirely filled in with concrete, and then we put water in here for the birds to have like a nice little drink out of. There you go, there's a bird. So I also made the water space coloured by accident. I don't really know what's going on. Anyway, so let's answer these questions. So blah blah blah. The curve C to D is plotted by this. So it's just a quadratic. Translated upwards. So if we plot it on some axes, this is what that curve would be in this domain. The height of the bird bath is 1.16 meters, and the diameter of the base of the bird bath is 0.4. So that's just this information here. Suggest the maximum depth of the bird bath. This is quite an obvious question to answer, and actually I think K is pretty straightforward. K is pretty straightforward to do as well. So why won't you split? So maximum depth, I think it's pretty easy to spot. It has to be 0.16. So the maximum depth is going to be 0.16, because if we look at this, this must be 1, this height here, because the graph is 1 plus kx squared, so the y-intercept must be 1. And since we're told that the height of the total bath is 1.16, well, that means that the depth of the bath, this bit, must be 0.16. Suggest the value of k. Well, let's just do that. So, or find the value of k. No, sorry, not suggest the value of k. Find the value of k. Well, we can just use. Sorry, we can just use one of these coordinates here. So, like for example, this endpoint is a coordinate of 0.2, 1.16. So if we just look at, well, we've got y equals 1 plus kx squared. So we could say that 1.16 equals 1 plus k times by 0.2 squared. And then we just work from there. And it gives us k equals 4. Alright, question C. Find the volume of concrete that you need to make the bird bath. So there's kind of two things going on here, or two parts to this. It's a little bit similar to the previous question that we did. So if we look at this, what we want to do is essentially think, well, if I have this line, which I'm going to colour red here, so this line, which is the 1 plus kx squared, I'm going to rotate it around the y-axis, and that's going to give me a kind of shape like D. So that's going to give me the volume inside that I've coloured in space coloured over here with this little bird. If I take this line and I rotate it around the y-axis, it gives me this space coloured bit here, that volume. So I kind of just need to think, well, the rest of this bird bath, although it's a rectangle here because it's the cross section, it's going to be a cylinder. So if I want to know the volume of concrete, what I'm actually asking for is the area, or the volume, found by rotating this area around the y-axis. So I'm kind of looking for this bit rotated around the y-axis. So what I'm actually going to do is I'm going to find the whole cylinder, so DC and these 0.2s, that whole cylinder, and then I'm going to take away the space coloured volume bit that I've got here. So let's work out what that bit is first. So this bit we're finding out is going to be this rotated around the y-axis. So let's do that. So if I do that a different colour, and then we can label it as appropriate. So there we go. So this bit could be orange. So I want to find the volume of the orange bit rotated. So find the orange volume, then subtract from from cylinder. So let's just do that. So this one we're going to be doing, because it's a rotation around the y-axis, so it's going to be x squared dy, and there's some pretty nice stuff going on here you might have already spotted. So x squared dy between 1 and 1.16, because this bit here is 1 and this bit here is 1.16, so it's these are the limits. X squared, we can see it from here, x squared is actually equal to just y minus 1 over k. So we can just use that. So pi 1.16 and 1 of y minus 1 over k dy. Can even factor out a k here. So we've got pi over k times by, let's just do it, because it's going to leave us with y minus 1, so it'll be y squared over 2 minus y between 1.16 and 1, like this. And then we can just work out what that is. So 0.0032 pi. I actually forgot to put a 4 here because we worked out k is 4 already. So now what we'll do is we'll just say, well, the cylinder is just pi r squared h. So if we do pi times by r, which is the 0.2 here, and then the h is 1.16, so it's pi times by 0.2 squared times by 1.16, which is 0. Where is it? I've got it written here. 0.0464 pi. So it's this one, the cylinder, minus the rotation. So so concrete volume is 0.0464 pi minus 0.0032 pi. It says do it to 3 significant figures, which is 0.136 meters cubed, I think. There we go. Alright. State a limitation of the model. So what is a limitation of this model? There's always a few different possible answers you can give to these things. I mean, it could be inaccurate measurements. The inside of the bowl may not be smooth, or they could need extra concrete to make it because the mould might not be accurate or something like that. Bit of a vague question, but those do tie in. I'll show you the mark scheme in a minute. Those do tie in with what the mark scheme is. And then it's later discovered that the volume was this, correct to 3 significant figures, which is different to what we had. Evaluate the model. So some sort of concrete answer is required. So use information to evaluate the model. Let me think, what does that mean? So I guess what we could do is we could say find a percentage error between the 0.136 and the 0.127, and then say it's because of waste, so it's not a good model. Or I mean, I don't really know what this is asking, to be honest. We could just say it's just a waste concrete because, you know, things overflow or people spill stuff, or I don't know. But what they seem to say here, it's a bit of a difficult question, that one. What they say is it's not good because it's a certain percentage lower, and yeah, so it does not look suitable because it predicts more concrete than was used. I mean, that seems obvious from looking at numbers to me. Bit of a weird question. Sometimes you get ones like that in the specimen papers. That's the whole chapter. Go through 5C and 5D, get the questions done, do the mixed exercise. Quite a nice topic in my opinion, and I'll see you in the next one. Bye bye.